Okay, we're on number 13. Using the limit definition, prove the limit as x goes to 2, which is a finite number, of the function x cubed is equal to 8, which is also a finite number. So this is the epsilon delta definition of limit. So let's go to the whiteboard, make it some attempt to do it, and let's write it down. And we're on this is number 13. So number 13, it's the limit as x goes to 2 of x cubed is equal to 8. All right, so it's epsilon delta. So first thing we do is we're being given that there's some epsilon greater than 0. All right. The next thing is to choose, and you're going to choose the delta. I just don't know what the delta is at this point. All right, we'll get there when we get to the last step, by the way. And we're going to suppose that the difference between x and 2 is less than delta. And again, I want to remind you that we don't want x to touch 2, so x is not equal to 2. And if that's the case, the absolute value of x minus 2 would not be equal to 0. So I'm going to put this over here. All right? Now we have to do this, the check part, the check. All right, this is, like, for me, the toughest part of the problem. So what are we checking? We're checking that x cubed minus 8, right? And we have to get this, we have to find that absolute value of x minus 2 in there. And that doesn't seem like the bad part to me. And the reason that I know to factor x cubed minus 8, and that's a difference of perfect cubes. So it's x minus 2. This is the tough part, though. I'm looking at a quadratic now, and I'm wondering how to get that. But what do I know about this over here? This is equal to the absolute value of x minus 2 times the absolute value of x squared plus 2x plus 4. And I know this is going to be less than delta because x minus 2 is less than delta times the absolute value of x squared plus 2x plus 4. And this is where trouble sets in. And the trouble is, how do you deal with that? And to look at that, I'm going to use what's known as a triangle inequality. And what I'm going to say is I have an addition problem. And I want to point out, like, if you took an addition down like a plus b plus c and took the absolute value of it, this is guaranteed to be less than or equal to the absolute value of a plus the absolute value of b plus the absolute value of c. All right? Now, typically see that triangle inequality like this over here, a plus b less than or equal to absolute value of a plus the absolute value of b. I'm just extending it. All right? So let's write this down. If this is true, I can write down that this is less than or equal to delta. And I got to be a little careful here. I'm going to be writing down the absolute value of x squared plus the absolute value of 2x plus the absolute value of 4. Well, I think I could simplify that somewhat. And let me see if I can do that. I'm going to write down, let me get my eraser out too. I don't need this anymore. I just used it. Okay, let's keep moving if we can. Looking at this. That's pretty easy. The absolute value of x squared is just x squared. So I can write this as equal to delta x squared plus 2 absolute value of x, and the absolute value of 4 is 4. All right? Now what I have to do? Well, I got to figure out the, I'm going to use that suppose part, but now I got to, this is the part where I got to write this min down now. And I'm gonna start off with 1. Let's see if that's helpful. So min, and then I'm gonna say the delta. Let's write this over here. 0. A little bit of work to do now. Absolute value of x minus 2 less than 1. Let me keep doing that, and that's gonna be x minus 2 is between 1 and minus 1. And I want to get the x now. And how do I do it? Add 2 to all sides. And you get 1, x, and then what do you get? If you add 2, you get 3, right? So I'm going to say the absolute value of x is less than 3. All right? And let me just think about this for a second. And I'm going to say, I got this part down over here. Let's get a bound on this now. So I'm going to say this thing here, the delta x squared plus 2 absolute value of x plus 4 is going to be less than something. Let's think about it. You got the delta. And the x squared, if I did that, I'm going to say that's going to be the most it could be is 9. It's going to be less than 9, by the way. So that's pretty safe saying that, by the way. And then 2 times the absolute value of x, 3 would be the bounded now, so 6, and then 4. And that's going to equal to 19. All right? Okay, so let's talk about what to make that delta. And the delta is going to be a number. Let's see, we want to make that an epsilon. So epsilon over 19. All right, if that were the case, that this would be less than or equal to epsilon. All right, so I think I'm pretty much done with that. And let's just put my QED down. QED. You know, black pen, red pen puts a little box down. A lot of books will do that. A little shaded in like this. And the same thing with me putting the QED down. So I think I'm done. Let me make sure I got everything written down for you. Yeah, I got everything written down for you. Thank you for paying attention.